3D lights add a lot of possibilities to how you can actually make your 3D layers look inside of After Effects. So let's go up to Layer, New, Light, and take a look at what our options are. There are actually lots of different types of lights that we can have inside of After Effects, and they each have some unique settings. Let's just go to our light type and choose Point to start, because this is probably the easiest one to understand at first. So let's just stick with Point for now. The color can be white, just make that pure white. Intensity 100% is fine for now. Leave the fall off set to none, and let's not cast any shadows yet. We'll just keep it nice and simple. Click OK, and now we have a light in our scene. This is what the icon for it looks like. You can see it's kind of like this sunburst kind of icon. And nothing really changed. The circle actually got just slightly dimmer, but it was so subtle you probably didn't even notice it. You can think of a point light kind of like a light bulb. It's a point in space that a light is emitting from. So if I was dangling a light bulb from the ceiling in this world, that's where the light bulb would be. If I click and drag this around, you can see that it's actually shading that circle. If I move it over here, the light's going to get dimmer until it gets super, super dark. And if I move it down here, it's brightest at this point and kind of falls off into the darker edge of this layer. But wherever I put this point light is where the light is going to be casting from. To visualize this even better, I'm going to switch to my two views horizontal so we can see that the light is actually in front of the circle. I'm going to change this to the top view and zoom in here nice and close so we can see what's going on. My circle is right here and the light is out here in front of it. If I click and drag this forward, you see that it's getting much more dark because it's so much closer to the same Z-plane as the circle. I'm going to need to move this down in order to get it to affect that circle more. And as soon as I move it behind that layer, it's pure black. That light is casting from behind it. None of the light is getting to the front of that circle, so it's just in complete darkness. Remember, my background is a 2D layer, so the lights are not affecting that at all. It's just there to give us something to see in the background. But as I move this light around the circle, you can see how it's affecting the layer. Let's make our scene just have a little bit more depth to it by duplicating this circle and just spacing it out from the original a few times. So I'll just put some around kind of in a circle pattern. So I'll just keep duplicating and moving these copies around until they're in a rough circle just around my scene. And that way we can see how the light is affecting multiple layers at the same time. I'm also going to rotate my camera up and to the side a little bit just so we can see this a little bit more clearly. Now with that point light, I can click and drag it around and you can see how when it's behind these layers, they're all in total darkness. When it's in front, that light is casting on them. If I move it in the middle here, then only these layers in the back, which we can see where that light is bouncing onto, are being lit up. Okay, so why are all of these layers 100% black? Well, it's because currently, since we only have one light, this is the only place in our scene that light is being cast from. And as far as After Effects is concerned, no other light exists. Obviously, in the real world, that's not how it works. Unless you are in a perfectly dark room with absolutely no sources of light and no way for light to get into it, this is never going to be a realistic way to light a scene. There's going to be ambient illumination or ambient light coming from someplace else, whether it's the sky or light bouncing off of a wall. You're never going to have just this one single source of light and that's it. Now, we don't need to worry too much about realism at this point because we're just learning how lights work, but this is a great opportunity to point out the next type of light. So let's come up to Layer, New, Light one more time. And instead of doing a point light, let's go down to Ambient Light. If I choose that, you'll notice that most of the options are grayed out. We just have color and intensity as options. Color can stay white again, intensity we'll leave it at 100, and click OK. So everything just got a whole lot brighter, and if you noticed, the ambient light is selected, but we don't see any icon for it in our scene. And that's because an ambient light affects everything uniformly. If I open up the controls for it, there are no transform controls because there is no point that it exists in. This is just a way to brighten up or darken everything in your scene at the same time uniformly. So if I open up the light options and we look at the intensity, it's set to 100%. If I turn my point light off, by just hiding it. This looks exactly the same as it would if I turn the ambient light off as well, because 100% ambient light is exactly the same as having no lights at all. But when you combine an ambient light with, say, a point light, then it's adding to that light. So we have a point light at 100%, but we also have ambient light at 100%, meaning that we're starting at a point where there basically is uniform light to everything, and we're adding more brightness to it with that point light. So I don't really want this to be 100% intensity. I do want this side where the point light isn't hitting these faces to be dimmer. I just don't want it to be 100% black. So let's dial the intensity of that light down a little bit, but not all the way, maybe 40%. So now we still have some value to these faces and a little bit of color, but it's not 100% gone. Okay? So that's the difference between a point light and an ambient light. But there's more to a point light. We haven't covered all of that yet. So let's collapse up the ambient light for now, leave it as is, and then collapse and open this one up again so we can see everything that we have access to in here. Obviously we have transform controls, but it's just position. There is no rotation because light is emitting from every single direction around this point, so rotating it would do absolutely nothing. It's another reason why it's called a point light, because it just exists at one point in space. Then we have light options, and there are quite a few options in here to go over. So let's just start at the top. Obviously we have the intensity. We can turn that down. We can go way beyond 100%. We can even go to a negative number, and it's going to act kind of like a vacuum of light. It's taking light away. This is something that doesn't exist in the real world, obviously, but because this is all just being calculated in After Effects, we can do these weird things. So that is an option. Let's just leave it at 100. Next is the color. We have it set to white, which means that it's not really going to affect the color of anything in our scene. It's just going to affect the brightness or the value of those colors. If I change this to something crazy like bright red, now it really is affecting our layers. It's changing the colors because we're adding a light color to it. I could make it a blue color, teal color, and it's going to add that color to my layers. Alright, so that is a way that you can kind of add some mood light to your scene. I'm going to leave that back down to white. Next is fall off, and radius and fall off distance both go with these. Fall off is a naturally occurring phenomenon with light in the real world. Basically what it means is the further away the light is, the less it's affecting the object it's hitting. So currently fall off is set to none, so no matter how far away I move this light, it's going to be affecting everything at the same intensity no matter how far away I move it. It gets a little bit dimmer on some of these objects as I move closer, but that's just because of the angle relative to the rest of the layers. So don't let that confuse you. If I enable fall off, and we say change it from none to smooth, you see that the layers in the back got a lot darker. They're no longer being affected the same amount as the layers that are closer to the light. If I adjust the radius of this fall off and make it bigger, you can see that it's affecting those further away layers more. So you can kind of think of the radius as a sphere around this light that's getting bigger or smaller as I adjust it to show you at what point the fall off begins to happen. The fall off distance is kind of like a second sphere, and I realize this is kind of hard to picture, so let me just make a circle really quick, and we're going to make this one with just a stroke this time, and I'll make it white. And I want to make sure that this is a perfect circle, and I'm going to turn on 3D. And it looks like I accidentally turned off the ellipse path, not the fill. Okay, there we go. And then I want to rotate this so that I can see it from the top-down view. So I'm going to press W on the keyboard to switch to my rotation tool. Click and drag on the X-axis while holding Shift to snap it to 90-degree angles, or 45-degree angles, and then just move this right over my light. Now I'm going to do something crazy with expressions just to illustrate this a little bit easier. And what I want to do is just link the size of this circle to the radius of my fall off. And I can do this really simply. I'm just going to add an expression. If you're not following along, don't worry, but I'm just going to make a variable called R for radius, and I'm going to make that variable my radius from my light. And then I'm going to plug that radius into an array for the X and Y size, and type in R for the radius of my light's fall off, and multiply that by 2 because The radius is half of the diameter, and the size value is the diameter from one edge to the other. The radius is from the center of a circle to the edge. So r times 2, comma, r times 2. What this is doing is taking the radius value, multiplying it by 2 so we get the full width, and applying that to both the x and y values of our circle. Again, if you're not following along, don't worry about it. You don't need to do this. I'm just illustrating how this fall off works. But now the size of my circle is linked to the radius of my fall off. So we can visualize exactly where this light is affecting in our scene. So let me zoom out a little bit so we can see all of this at once. And I'll make that circle just a little bit thicker so it's easier to see. So if I make the radius of my light fall off smaller, you can see the area that the light is affecting these other ones. But if I pull it back a little bit further, you'll notice that these circles in the front are still being affected. Even if I go down pretty far, this circle isn't touching those, so why are these objects still being affected by that fall off? Well, it's because of the next setting, which is the fall off distance. And I'm going to visualize this one as well. So let's rename this the radius, duplicate it, and call this the fall off distance. Okay, so I'm going to collapse this layer, double tap E to bring up that expression. And what I want this circle to be is basically the same as the radius, just with an addition of the fall off distance value. So to simplify this expression even a little bit more, I'm going to add another variable, and I'll add an F for fall off distance, and I'm going to link that up to the fall off distance. And then I'm just going to change both of these to be times 2, so I don't have to do that calculation in my array. And I'll just say r plus f, and then r plus f. So it'll be the radius times 2 plus the fall-off distance times 2 for both the x and y values of this fall-off distance. I'm going to make this a magenta color just so we can distinguish the two circles. Okay, so now this should make a little bit more sense. You see that these circles within the magenta circle are being affected because they're within the fall-off distance. And I realize I didn't really explain what fall-off distance means. It's basically the distance between the actual start of the fall-off and where the light actually stops affecting other objects. So you can kind of think of it like a gradient between this point and this point. The light is most extreme at this point, and it gradually gets dimmer and dimmer the further out you go. And outside of this second circle, the light is no longer affecting objects. So if I bring my fall-off distance in a little bit, it's going to be a much tighter fall-off, and this light isn't going to affect as much. But if I move it around, and I actually forgot that I needed to parent the radius and fall-off distance to this point, and I'm going to hold down Shift while I do that, because if you hold Shift, it's going to basically move all of the transform properties to the parent when you're parenting it. But that also reset my rotation. So let me just grab both of those, rotate them down again. But now those circles are parented to the light. So if I move it around, we're going to see that fall off move with it. So let's move this down so that it's in line with these circles, and then increase our radius, as well as increase the fall-off distance. And now we can see that since this white circle, the radius of our fall-off, is touching all of these objects, the light is actually affecting them more. And if I turn up my fall-off distance, it's going to just make that fall-off a little bit smoother. So that is how radius and fall-off work. And hopefully that little visual illustration really helped you understand that. Now, we do have a second option here, which is called inverse square clamped instead of smooth. If I turn that on, you can see that things just updated visually a little bit. If I undo and redo, it's just a different way of having the fall off be calculated. Inverse square is more physically accurate to the actual real world lighting, and smooth is kind of more like a linear fall off between 0 and 100% basically. So if you're going for realism, then you're probably going to want to use inverse square clamp. Just set your expectations, because again, After Effects is not a true 3D program, and it's very difficult to achieve a lot of realism inside of a program like After Effects. Alright, next up is Cast Shadows, Shadow Darkness, and Shadow Diffusion. So Cast Shadows is set to off currently, but if I turn it on, nothing really changed. And that's because 3D layers themselves also have something called material options. If I open this up, material options, we saw this before, but we didn't take a look at what it actually is. So let me expand this up and we'll twirl that down. The first option is cast shadows and it's set to off. So by default, 3D layers cast shadows are turned off. If I enable that, still nothing has changed. To see this, we're going to need to take a few more steps. So let's just copy the material options. I'll just select it and press Command or Control C, then select my other circles and say Command or Control V to paste. And now we're starting to get something happening. We're seeing some shadows on top of these other circles. If I move this around, you can see that, sure enough, this light actually is casting shadows, and these layers are also casting shadows. That's great. I'm going to turn off my radius and fall off distance because we understand that now. We don't need to see it anymore. But to see this even a little bit better, what I'm going to do is make a new solid layer and make it really big. So I'll just make it like 2000 by 2000, and I'll make it kind of this same bluish color. Okay, click OK. And then I need to enable 3D on that layer, and I'm going to push it back behind all of the circles. Okay, since this light has that fall off, and it's the only light in our scene besides the ambient light, that background is not getting lit up very much at all. So what I would probably want to do here is balance out my lights by turning up the ambient light, and I press T to bring up the intensity with that selected, and then turn down the point light a little bit. So maybe I'll have 70% ambient, and on this intensity of the point light, I'll just turn that down a little bit so that my lighting is a little bit more balanced out. So I'll rename this layer wall, and then I'll duplicate it and call it floor, rotate it on the x-axis so it's flat, and lower it down below those circles so that I'm not intersecting any of them anymore. It's basically just below them. And then move it out in Z-space so that we have that intersection between the wall and the floor. So I'm just barely trying to overlap that so we don't have any distance between the floor and the background. Now as I move this light around, you can really see how these lights are actually casting shadows using these objects. So this is a lot of fun, and it can add a lot of realism to your otherwise pretty flat After Effects render. So let's take a look at some of the options we have with these shadows. I'll just move the light right about here. And under our light options for the shadow section, we have shadow darkness and shadow diffusion. So the first option is pretty self-explanatory. It makes the shadows darker or lighter, right? So we can turn down the intensity of those shadows, or we can really crank them up and make them nice and visible. But we also have a shadow diffusion. So if I zoom in here nice and close so we can see this shadow really clearly, and I turn up the diffusion, can see that that is making a much more realistic looking shadow, because the parts of the object that are closer to where the shadow is being cast are much sharper, and as they get further away from the part of the object that's actually casting the shadow, it gets blurrier and softer. It diffuses that shadow. We can even see this in the top-down view. If I move this around so we can see all of these circles, you can see how that diffusion is making these shadows really soft compared to here where there is no softness at all. It's a really nice effect and much more realistic to the real world. And that's the end of the options list for a point light. Now that we know how that works, let's take a look at some of our other lights. So I'll just turn that one off for now and add a new light. Go up to Layer, New Light. And Spotlight is the next one that we want to look at. So you probably have heard of a spotlight. You might have a pretty good idea of what that is. I'm again going to leave the color at white. The intensity at 100 is fine. And then we have some other options in here, like cone angle, cone feather. We're just going to leave them at default for now and click OK. So with my top-down view, I'm going to zoom out so we can see it a little bit better. And this icon for this light is much different than the point light, which was just this little sunburst icon. So what is this new overlay telling us? Well, as you can see, it's the shape of a cone. So that kind of makes sense. It's a spotlight. It has cone options. But the difference between this and a point light is that it's not emitting in every single direction. It's emitting towards a point of interest. If I twirl this layer up and go into my transform controls, you see that it has a point of interest just like a two-node camera. And I can click and drag that point of interest just like a two-node camera. So this concept actually should transfer over really easily now that we understand how a two-node camera works. We can give the light something to look at, and when we move the position of the light around, it's always going to be pointed at that point of interest. And if we go into our light options, we have this section for cone angle and cone feather. You can kind of think of this like the field of view of your camera. If I turn the cone angle down, the cone shape gets narrower, and you can see how this is becoming more of like an actual spotlight that you would see in, say, a performance theater. So I can make this about the size that I need it to cover this circle, and you can see how it's falling off and hitting that background in the wall as if that was kind of like a stage. The next option is cone feather. So if you pay attention to this edge right here where it's feathered, if I turn it all the way down to 0%, then we're just going to get a harsh cutoff between the light and dark areas. If I turn it way up to 100%, then it's going to be much softer around those edges. So those are the only other two options that are unique to this cone light. We still have fall off, which I could turn on to inverse clamped, and then you see that it's hitting this circle a lot brighter and it's fading off into the distance a lot more. If I turn my radius up and I turn my fall off distance up, then it's going to be affecting more things in the background. That light is going to travel further, but it's the same concept between spotlights and point lights. Now I actually have cast shadows turned off, and that's why the light is kind of just going straight through this object. So if I turn cast shadows on, there we go, we see those again. I can turn the darkness down a little bit. I can turn up the diffusion. And as I'm doing this, you can see that it does affect the render time. The more diffusion you add to your lights, the more 3D objects casting shadows you have in your scene, the longer it's going to take to render. But that's just the cost of having these cool looking effects. So that's spotlights. We have one more light to cover. So let me disable that spotlight and go back up to Layer, New, Light. And go to Light Type and choose the first option, which is Parallel. Most of the options on this one are grayed out. Let's leave Color at White, Intensity 100, and Fall Off to None for now. We can also leave Cast Shadows off to start. Click OK, and our scene got pretty bright pretty quick. So let me zoom out a little bit so we can see what's going on. And the icon for this type of light is kind of this circle with 3 arrows coming off of it. The easiest way to think about a parallel light is the sun. The sun is millions and millions and millions of miles away from us, so the light that's coming from it is extremely direct. And what that means is that the shading is going to be very uniform. It's coming from one direction and it's blanketing everything that it hits at the same value. This light does have a point of interest, just like a spotlight, so I can kind of give it an area that I want it to be pointed at, and then I can move the light around. So let's say I want to move it up a little bit. You can see that it's really affecting the entire scene quite a bit. And the reason for this is because the angle that this point of interest is giving us, the line connected from the light to the point of interest, is the angle that the light is actually coming from, and it's shooting the entire scene at the exact same time in this very uniform way with that same intensity of light. It doesn't matter how close or how far away the light gets on that z-axis. All that matters is the angle. So if I twirl open my transform properties, and we take a look at our position and our point of interest, I could bring the position of this light really close to the point of interest. And I'll just drag this all the way down. And if I adjust the position now, just so that the angle of the light is changing, you can see that it's drastically affecting how the scene looks. But everything's being changed equally. This is a great light to use if you want very flat shading. If we go into light options, we do have the same options of intensity, color, and fall off. So if I change this to inverse square clamped, that is going to have that same fall off. And you can really see that radius now visually just because of the nature of this parallel light. But if we're thinking about a parallel light like the sun, it's not going to have a fall off because it's such a massively bright light source and it's so incredibly far away. It's lighting everything equally. So let's turn that fall off back off so this light just floods the entire scene. But let's turn on cast shadows because this is something that's unique to parallel lights that we need to understand. As you can see, the angle of the shadows is changing depending on the angle that we're getting between our source of light and the point of interest. It doesn't matter where this light is in the scene, the shadows are always going to be exactly the same as long as the angle between that light and point of interest are the same. What a parallel light does not give us the option to do is control the shadow diffusion. We can change the darkness, but it will not have that diffusion. And this is again something that's basically mimicking real world light. If we use that sun as an example, direct sunlight is going to cast shadows that are extremely crisp. They're not going to have that diffusion because the light source is so far away. So those are our light types. We have the point light, the spotlight, the parallel light, and the ambient light. No matter what I'm doing, I almost always have an ambient light in my scene just to brighten everything up and fill in the dark parts a little bit. And I usually use one of the other three types of lights depending on what I'm going for. Obviously, if I need that shadow diffusion, then I can't use a parallel light. And if I need a very focused area of light, then I'm going to use a spotlight so I can control where that light is going. Other times, I don't really care where the light is going, I just need a bunch of light being emitted into my scene, and then I'm just going to keep it simple and stick with a point light and mess with the intensity, the color, the way that the shadows are being handled. It all just depends on what you're trying to do.